Alright, hello and welcome to CSCI 40. The reason this isn't a full screen PowerPoint is because I get cooler pens if I keep it this way. Okay? So let me start by just saying that you're getting all of this, you're getting all my slides, all the code that I write, so don't feel the need to write it all down. Just sit back and watch. Okay? It's your standard first day lecture today, so I'll talk about myself, we'll get into all the little rules of the class like you have to do, and then we'll actually get started with learning a little bit about C++ and programming, so that's exciting, so look forward to that. So let us start with a little bit about me. I'll make it fast, okay? So, hi, my name is Lawton Nichols, I use he, him pronouns, and just in case you never come to office hours, let me show you my face. I'll just start a random Zoom meeting. And sorry, my webcam is horrible. It looks like there's no light in the room, but I promise there is. So here's me. It's nice to meet you all. Let's close out of this again. And yeah, I will respond to Mr. Nichols, Dr. Nichols, Professor Nichols, if you want to get fancy. But honestly, I would prefer it if you just call me by my first name. Please call me Lawton, if you feel like it. I went to Fresno State, not too far away, for my undergrad. I got a computer science degree. And then I went to UC Santa Barbara for my PhD in computer science. Okay? So, yeah, I got all 3 fancy degrees, all that you could get. So ask me all that you want. And this is my second year teaching here. Okay? It's actually the first semester that I will be on campus, which is surprising and interesting all in itself. So there's that. And other than doing teacher things, I also like to do some human things. I like to dance and also play guitar. So yeah, that's me. Here are some other living things that are in my apartment. So here's my cat. His name is Alonzo. He's older now. This is an older picture of him. And he was named after Alonzo Church. And he was the PhD advisor of Alan Turing. So I encourage you to look his Wikipedia page up. He did some really cool things, and so I am paying homage to him in my cat. And then I also have 2 beautiful moss balls. I gave them silly names that I just won't repeat here. Okay, so that is about me, and yeah, just thank you for putting up with me throughout this semester. It's going to be another interesting one in the middle of a pandemic, but we will get through it together. Okay, so yeah, let's keep on trucking. This is going to be a long bit of the lecture, and I apologize, but it's just that stuff you got to say. But I'm going to go fast, just to make it so that I don't go crazy, and neither do you. So remember to read the syllabus. That's on you to read. There are some things that I won't be saying that are that's all listed in there. So make sure to look at all that. Okay? So this is not an in-person or synchronous class, so I'm going to skip this one. This is an online class, okay? So what we're going to do, it's asynchronous. I'm going to be recording every lecture and lab, so just look forward to all the videos, okay? And it's silly, but I am required to take attendance somehow, even though you're not really coming to class. And so the check-in surveys that I have on our Canvas, so we go to the modules page, those are going to count as attendance, okay? So if you just remember to do them, and that is what's going to track whether or not you were here or not, and whether or not I should drop you. Okay, that is just how it has to be. So make sure to do those, and they are a very easy 5% of your grade as well. Okay, so that's that. And then we're going to pretend that this is a Monday-Wednesday class, because I'm teaching an in-person CSCI 40 that is also a Monday-Wednesday class. And so we're going to try and keep everything aligned as best as possible. So here are my promises to you. I'll have the first video up of the week by Monday, and the second video of the week up by Wednesday. Okay. And there will be a lab released one of those days as well, usually. So yeah, that's that. And because there's no set time for the class, I'll give you a window, like a 24-hour window at least, to start and take exams. So that should give you plenty of time, no matter your schedule, to get started on it. Okay? And then because it is an exam, though, it's going to be timed once you click start. So you have a window to take it, but you have to, it's like an hour and 15 minutes once you start it, or like an hour and a half. We'll figure it out. Oops. I just dropped my pen. Hopefully it still works. Yay. Okay, so yeah, that's what's going to happen. Let's talk about expectations, because this is a challenging class. I want to say that up front so that you know what you're in for, okay? It is, if you've never programmed before, and we don't assume that you have, this is the first class, right, for that, it's a very different way of thinking about things. It's brand new, okay? It's a new way of thinking, and there a lot of work goes with that because we have to get you up to speed quite quickly, okay, with something brand new that you haven't really learned before. So prepare to do some work to get everything in your brain, all right? The one good thing about all of this is you're going to learn a lot of new stuff, but you're not going to have to really memorize it. So hopefully that seems like a plus to you. You can't really like memorize any answers and expect to do well on the tests because it's all going to be you writing a program, and there's a million ways to write the same program, okay? So it's almost like writing an essay in that sense. That's really cool to think about, I think. Yeah. And if this class ever gets to be too much for you, that is totally fine. We have CSCI 1 here that will prepare you to take this class, okay? I teach CSCI 1 as well. I take things super duper slow there. We learn Python, and we get ready to take CSCI 40, okay? So if you need to, take that class instead, and it will prepare you for this one, all right? And then, yeah, this is a 4-unit class, and so you know the rule. Expect to do well, you're in class for 4 hours. That's what 4 units means. And then you should double that number, and that's the amount of time that you should be spending outside of class to do work. And that's why they call like 15 units a full-time student. Now you know the math involved in that. So that might happen some weeks, okay? You might hit that rule where you do really have to work for 8 hours. So prepare for that, okay? And I'm not trying to scare you or ask you to drop or anything. I will be here for you as much as humanly possible. I'll be on Discord late at night. I will be in several hours of office hours a week here to help you and answer your questions, okay? So this is a challenging class, but I'm going to help you meet that challenge. Okie dokie? I will be here, and your peers will be here for you as well. So yeah, that's that. Let's talk about some other things. The college is really, really nice if you need things like a laptop or a better internet connection even. They're giving out MiFi routers that just let you connect to wireless internet. Look at the resources page on our Canvas up here at the very top. Okay? That's where you can go and get access to these things. So please take advantage of the technology loan program if you need to. Really cool stuff and super helpful. All right. Then we can move along to the syllabus, and I'll just go straight to the things that you probably care about, and you can read the rest, okay? So let's get it in a window by itself. Yay! So here is us. We're this one, 80082, and yeah, let's scroll down to the stuff that you're going to care about. So definitely read all this, but this is what we're going to get to in just a second. Okay, so the assignments that you can look forward to are homeworks and programming assignments, I call them. So you're going to read stuff out of your textbook. That's going to be a reading assignment, and then you're going to have 2 different kinds of programming assignments. A Xylab, which also exists in your textbook. That's kind of like getting you ready to do what I call a lab, okay? And that's going to be done on our class server, okay? So hopefully you've got your account and you've connected to that by now. So that's the kind of stuff that you're going to be doing. And then we also have check-in surveys. I talked about that just briefly. That's your first one is out. Please do that. That is me forcing you to psychoanalyze yourself each week. And it helps me learn more about you and what you're struggling with so that I can change the class up and make sure that you don't struggle next week, okay? So that is helpful for me, and for you it's a very easy 5% of your grade as well, okay? There will be 2 midterms, one a third of the way through the class, so week 6, and one 2/3 of the way through the class, week 12, and then the final is at the end. I hope that makes enough sense to us. And then, yeah, let's talk about your grade now. So your grade's going to be calculated this way. Your Zybook's reading, so reading a textbook chapter, it's an interactive textbook, and we'll talk about that. So that's going to be 10%. Then 10% is going to be from Xylabs, so programming assignments inside of your textbook. And then the bulk of all of your grade in this class is going to be from the labs that we're going to work on the class server. Okay, so these are the programming assignments that I care about you doing well on. Everything else is you getting prepared for that. Okay, and then 5% of your grade is going to be from those check-in surveys. So just write a few sentences. It's very easy to get it done. Easy 5%. And then each midterm will be 15%, so there's going to be 2 of those, so 30 total. And then finally, the final exam will be 20% of your grade. Okay, so Hopefully that all seems fair, just a normal grade calculation scheme. And that is everything that I wanted to talk about there. I will give out extra credit. I like to give out at least a letter grade's worth of extra credit every semester, so look forward to that around exam time. Okay? That's the idea. And then the final exam, because this is an asynchronous class, there is no time to take it, so here's what we're going to do. Just go down to the important dates. I'm just going to give it to you throughout a 24-hour period, okay? I'm going to pick Monday through Tuesday, and that's when we're going to take it. So Monday and Tuesday, finals week, sometime you can start and take the final, okay? Hopefully that seems fair to you. That's how we'll do things. Okie dokie, so that is the bulk of the logistics and all that. We still have more to talk about, but I think that was what you really cared about. You can probably fast forward from now. Watch me on 2 times the speed, and it will still make sense. So the next thing that I want to talk about is due dates. For my sanity and yours, I think, I'm going to make it so that every assignment in this class, except for the check-in surveys, will be due at 5 p.m. Okay? No matter what day it's due, it's going to be due at 5 p.m. All right? And let's make sure that I'm awake when things go wrong, and you can get help. Okay? So that's why I'm doing it that way. And just plan on every assignment is due at 5 p.m. Okie dokie? Except if any of these things apply to you. I have some exceptions to this rule, and let me know if the exception applies to you. So if you are a working student, if you work at least half time, so 20 hours a week, school does not count, by the way. It's definitely your fault if you're taking 20 units. If you work at least 20 hours a week, I will extend your due dates an extra 7 hours, so you can stay up late and get the assignment done, okay? And then if you work at least full-time, so 40 hours a week, or if you care for a child or something else that is the equivalent of a full-time job, right, then I'll give you an extra 15 hours after 5 p.m. to get your assignment done. So you can either stay up late or wake up early and get it in, okay? So I hope that seems fair to everyone, and that is those are some exceptions that I allow for my assignments. So let me know, like on Discord or something, if any of those apply to you, and we will make sure that your due dates are appropriate. Okie dokie. So that's that. Let's talk about late submissions as well. I am super lenient when it comes to late submissions. I will accept late reading assignments, and Xylabs, and labs, and check-in surveys up until the last day of instruction, in fact. So you're welcome. But the second it's late, you get 50% penalty. So you get half credit, okay? Silly enough, Zybooks doesn't tell me when you complete something late, so it might show up as a 0 in your gradebook. Just let me know, and I'll give you your half credit back if you submit a Zybooks assignment late. It's just a weird quirk of the way it talks to Canvas. That's all. Okay, so that's late submissions. I'm also very lenient with dropping a few assignments. So here's what's going to happen. I will drop your 3 lowest labs, your 4 lowest Zybook readings, and your 4 lowest Zylab. So you get a bad score once, it's like it never happened. Okay? So that's not too horrible of a deal, I hope. And then I said the word Zybooks a lot. Let's talk about that. That is our textbook, okay? These are the people who made it. Our textbook is virtual. It's interactive. It's crazy. It's really cool. And I'm going to give you homework out of that to complete, as well as Zylabs, which are programming assignments, okay? So you got to buy it, but it's really, really worth it. All this interactivity will make you a much better programmer. It is seriously the best textbook I have ever seen for this class. So it's really, really good, okay? You can either buy it from the bookstore or directly from the Zybooks website, and definitely go and read the fine print. I'm not sure which one is cheaper, which one's easier to return, things like that. But to get to the first assignment, or to get to Zybooks and buy the book, or to get to the first assignment, just click on it on Canvas. Okay, so here's like the first reading assignment. Here's the first Zylab. Click on one of those, and it has this little button, load it in a new window, and that will open up Zybooks. Okay, and so it'll present you with a page asking you to like buy the book, and once you've bought it, it will give you access to this page here. Okay. And so here's like the first chapter, yay! And look at how it's super fancy. It's got animations that are going to teach you all these concepts. It's super duper cool. And yeah, here's everything. And here's like the home page of the book, and you can click and see what's up. Definitely, you can also look at the assignments. I've released every single assignment for this class, so you can get started early if you have no life. And Do not, though, pay attention to these due dates. These due dates are just the last day of instruction. Pay attention to the due dates on Canvas. Those are the real due dates. Okay? So that's SciBooks. We have looked at it. Yeah, all the assignments are up, and definitely read ahead if you have time and you can. I really want to stress that you should start early for the first 3 reading assignments, because those chapters get set up every single thing for the rest of the book, these 3 chapters. And there's a lot of content there, okay? So because of that, I really want you to start early. There is a lot to read, okay? So I'm just warning you now, okay? So that's that. And then to contact me, you can totally use Canvas if you want, but I would strongly encourage you to use Discord instead. So hopefully you've already gotten on there. But here's what it looks like, and we have our own little channel just for ourselves. So here's the main Discord. Once you join my Lawton's class Discord, you'll have access to just these 2 first channels, Welcome and Guide. Scroll up to the top of the Welcome channel, click the 100 emoji, and then click what class you're in. So you'll click the cat. And then also add your pronouns, please. And after that, you'll have access to all these things down here. Announcements, general, random, and then our CSCI 40 specific channel. Okay, so this is where you can ask public questions and talk to your peers. So that'll be fun. You can also talk to some of my past students who are still on here. So that's that. Definitely ask questions publicly when you can, because I'll probably be asleep the second before midnight if you're trying to still work on something, and your peers might be up. So ask a public question when you can, but do use your judgment. What I don't want you to do is share answers, of course, or tons of code publicly, okay? That should be a question just for me, okay? So definitely use your judgment. Know when to privately ask me a question via a direct message, okay? You can do that on Canvas. You can just click my name or right click and be message. I don't think it works because I am me, but you will see a message button. Okay, so that's how you can send me a private direct message. And definitely take advantage of Discord. I'll be on it all the time, and I get notifications on my phone. Okay, so that is that. The office hours as well. Let's talk about those. Please come to office hours as much as you want. They are for you. And on days when things aren't due, there's not usually a lot of people. And so there's plenty of time for me to do whatever you want me to do. Okay, so there's the office hours link on the homepage. There's also the same thing on our modules. Now these times might change, the green things. This is when I want to have my office hours. We're still scheduling meetings for the semester right now, so this might change. So just look at the page before you attend. But to attend the office hours, just click my Zoom link up here or down here. Okay, either one. That is where you will go to find me, and I can help you with whatever you're wondering about. Okay, and you can also totally make an appointment if something comes up and you need to meet with me. So yeah, that is that. And then finally, before we're almost done with the logistics, let me just say this now. Programming, it really is something new, and you are going to get stuck. That's just a fact of life as you start out and as you continue your computer science journey. So let's do this. Let's pick a number. Let's say if you have been stuck for 30 minutes on something and you don't know what to do next, then you should ask for help, either as a public question if it's appropriate, or as a direct message to me, or come to office hours, whatever you need to do. You should start asking for help after, let's say, 30 minutes, okay? Because it's my job to get you over whatever you're struggling on so that you can struggle on the next thing, okay? That's the idea. So definitely take advantage of that. There is no virtue in staring at your screen for 2 hours trying to get something yourself. Sometimes you need an extra push, and that's what I'm here for, okay? Though, if you are stuck for 29 minutes and then you get it, that is not a problem. That should be expected, okay? So look forward to that. That is just how computer science is going to work. You will get plenty of experience with, you'll understand this slide a whole lot more once you get started, I promise. But yeah, do ask for help when you need it. Don't stay quiet. All right, so the next thing that I want to talk about, the final logistics thing, yes, we made it, is the class website. Okay, so I want to take you there. I do a lot more things on the class website for in-person classes, but we're going to use the class website to look at our lab grades. So I've given you an account there. Okay. Let me know if you added the class late and you didn't get an account that I can help you with. Yell at me on Discord. Okay. So in fact, I've made you 2 separate accounts. One is on the class server, Hopefully you've already accessed that one. And the other one is on our class website. It's in our web browser. Okay, so they have the same username. Okay, there's a special way that I gave everybody a username. It has to do with your last name and your ID number. And the default password is the same right now on each account, the class website and the class server. But they are two separate accounts. Okay, so the second you change your class website password, it is not the same as your class server account. You can have the same account name, because you do, and then you can change the password to two separate things on both of them. Okay, so the second you log in on the class server, it will ask you to change your password anyway, but on the class website, it's still the default. Okay, so just keep that in mind. But here's the class website. It is www.lautensclass.com. Please go there and then log in. So if I log out, this is the page you'll see the first time. So enter in your username, and your password is the same as your username right now. So what is your username? It is your last name, all lowercase, no spaces or hyphens, an underscore, and then your student ID. Okay? So if this is your last name and this is your student ID, this would be your username. If this is your last name and this is your student ID, this would be your username. Okay? And it's also your password right now too. Okay? So that's the idea. Let me know if you can't log in, and I'll get you on there. If this were an in-person class, we would be doing attendance through this. Okay? So you see these 4 apps. I have some extra ones, but this is the place you'll be caring about, this lab grades page. That'll tell you, that'll let you look at your lab grades in a pretty way. Okay? So that's the class website. Make sure you can get on there. And now let me check the time. Yeah, we're doing great. So let's talk about computer science. We made it. All right. So yeah, let's get started with computers just in general, and then we'll get into some C++ as well. All right. So there's a lot to talk about, just to get you up to speed. So do not be scared. You can rewatch the lecture, of course. You can stare at these slides, but really the best way to study, I would say, is to try everything I do yourself. Okay. So let's get started. Here are some goals that I have for you. And then I have some in-class questions that I like to ask. I'm still going to ask them of you, but I'm not going to have you get into groups or anything, because we're all virtual right now. We're not online at the same time as me. So yeah, this is what I like to do. It's called peer instruction, asking in-class questions like this. And so I'm going to pause on a bunch of in-class exercises. And because our mascot here is called the Crush for some reason, I'm going to call our in-class exercises, which you can abbreviate to ICES, as crushed ices, of course. Okay? So this is what I would be asking you if this were an in-person class, asking you about yourself, what your major is, what you think about the Linux/Unix terminal, which we'll be learning in the class, and then if you've ever programmed C++. I don't expect you to have any experience with either of these. That's okay. But yeah, that's just to get to know you. You'll let me get to know you in your check-in survey instead. All right, so that's that. Computers and programming. Let us begin. Are we ready? So, yeah, let's talk about programs. Because programs aren't too hard to think about. They are really just recipes, right? If you've read a recipe and you've made something based on one before, you know how to program, really, okay? A program is a sequence of, or a bunch of, little algorithms that like to work together, and that's a fancy word that you might have heard of before. An algorithm, all that is, it's a sequence of steps to solve a problem, okay? So it's just a bunch of mini recipes, okay? That's all. And so my question for you is, think about, if I'm like an alien, I've never heard of a peanut butter and jelly sandwich before, how would you tell me to make it? How do you make a peanut butter and jelly sandwich? I'm going to pretend that I'm a computer and you're writing this program that makes a peanut butter and jelly sandwich. How would you write it? And I will follow your instructions, okay? That's the idea. So think about that. Pause the video for a second, and I promise this is a useful question to ask yourself. But yeah, assuming you've got an idea of your algorithm for making peanut butter and jelly, it probably sounds something like this. You take your bread, right? Here's my bag of bread. I don't know. This is what bread looks like, right? It's in a bag. There's my bag of bread. And then you're like, okay, get your bread, get your peanut butter, and get your jelly, and then put them together, all right? So as a computer, what I would do is, okay, I got my bread. Here is the peanut butter jar. I'll put that right on top of the bread, and then I'll take the jelly jar too, and I'll put that right on top of the peanut butter jar. And so that is me following your algorithm for making peanut butter and jelly. That's exactly what you wanted, right? That's a peanut butter and jelly sandwich. Just take bread, peanut butter, and jelly, put them together. And obviously that's not what you wanted, right? So this is where I say that a computer is very, very smart, but also very, very dumb. All right, so you have to talk on a computer's level. If you want it to do something specific, you got to get really specific. You got to say things like, get out a plate, take 2 slices of bread out of the bag, open the peanut butter jar, get a knife, get some peanut butter on the knife, put it on one of the breads, things like that. That is how you write a program at the level that the computer can understand it and do exactly what you want, okay? And this idea, thinking at this level, is called computational thinking, okay? This is by far what I'm trying to get you to learn in this class, how to think computationally, okay? That is just thinking in terms of all these little tiny operations that the computer knows how to perform, and that involves, in order to get into these operations, you have to break down a problem into little tiny pieces that the computer knows how to do, okay? And you also have to be careful of the order in which you do things. Like, you can't take the peanut butter, put it on anything when you don't have the bread out yet. All right, so there is always a concept of ordering involved too. Okay, so that is a program in a nutshell, and that's my best explanation, my fanciest example of why computational thinking is important. Okay, so here's a fun meme that also has to go along with that idea. So feel free to stare at that for a second while I get some water. All right, so yeah, now you know what programs are. So these are like a bunch of important things we're going to cover in this class, like algorithms. You know what that is now. It's just a recipe for how to make a program and do what we want. We think computationally. We're going to really care a lot about testing our programs as well in this class. That would be like what? Eating the finished sandwich, making sure it tastes good, checking our program to make sure that it does the right thing. Then we have assumptions. You have to think about the assumptions before you write a program. Like, what do you need? What's required in the solution but not mentioned in the problem? Like a plate, like a knife, yeah? All those things. Similarly, like if you want to light a birthday candle, like the manufacturer is making sure, like, you're not going to successfully sue them if you try to light the candle underwater, right? And it doesn't work. So there's always implicit assumptions that you have to keep in mind when you're writing a program. And then also finally computational thinking. That's thinking sequentially, clearly, and at the right level of abstraction that the computer can understand. And that is the key of this class. Okay, that's what I'm trying to teach you. Okay, so those are the things that you're going to learn. Are you ready? So we're almost ready to get into our real first programs, but first I want to just teach you about a few pieces of the computer because those are going to be very important. Okay, so at a very high level, this is what a computer is. It's just a bunch of things working together. You got your input devices, the important bits, your output devices, and memory is also very important, okay? So what is an input device? It's just a way to give information to the computer. So through a keyboard, you press some keys, through a mouse, through a touch screen these days. Those are input devices. Output devices are the opposite, right? It's ways to get information from the computer. That is like your screen, your display, or your printer even, things like that. And then where all the work gets done, of course, is in your computer's processor, or your CPU, right? And we say that's the brain of the computer, right? That's going to run your actual program. It makes it go, right? The fancy term for that is execute. It's not like you're killing your program, you're running it, all right? So that's just a term that you're going to get used to if you haven't heard it before. And then, yeah, memory is also very important. That is, if it's not the brain, it's also very important as well. It's a second part of the brain, let's say. Your main memory is usually called RAM, right? Random access memory. That stores information about programs that are currently running on your computer, okay? When you want to run a program, it's always getting copied into the main memory before it gets run. And that's why if you want to run a lot of programs at once, that's why you need more RAM, right? That's hopefully that makes a bit of sense, and you've heard of all that before. Main memory interacts with secondary memory. That's where the programs are stored originally, right? When your computer is turned off, everything's on the hard drive or the flash drive, right? And so that's secondary memory. there's a lot of space, it holds lots of info, but it's very slow to access. So that's why we bring it all to the main memory when we want to work with it or to run things. Okay, so that's like the orchestra that is a computer. And now we're ready to talk about C++, which is the language we're going to be learning in this class. Okay, so it's a programming language. It's been around for a while. It was invented by a nice Danish man named Bjarne Stroustrup. I think that's how you pronounce his name. Yeah, and then it comes from a long line of languages before it. It was based on the C language. So it went from C to C++, and that's a funny thing. That's a joke, actually, that I think by the end of this class I will get you to laugh at, because I'll teach you what the plus plus means. C++, it's called a high-level language, okay? So it looks a lot like English, like you're talking to the computer using English, more than the ones and zeros that make up a real program that's running on your CPU, okay? So that's why we call it that, a high-level language. It's also what's called a compiled language, okay? So that means the program isn't run using the English. We have to first convert it to the ones and zeros before it runs on your computer's processor, right? So there's another program involved called a compiler that converts your program that looks like English into those ones and zeros that your computer can run, okay? So here's a program. It looks like English. The ... You send that through a compiler that spits out the ones and zeros, that is your actual program that can run on the CPU, okay? Yeah, that's the idea. And so this is what you give your computer, you load it into main memory, it gets run, and we're off to the races, okay? So do not be scared, but I'm about to show you the simplest possible complete C++ program. The simplest possible C++ program is the one that does absolutely nothing at all, but there is still some content involved, so let me show you that, all right? So I'm going to make a program called, let's call it do-nothing.cpp, okay? And don't worry too much about what I'm doing on the terminal right now. I'm going to teach you all that later. So vim, let's call it do-nothing.cpp. And the simplest possible program just has a main function, we say, with some fancy symbols and things, and it returns 0, okay? These 3 lines. That is the simplest possible C++ program. It looks like that, okay? So get used to this, memorize this. Eventually, that is going to be the first thing that you write when you write a program, a main function. So this does absolutely nothing. Let me prove that to you. Let me open up a, oops. Let's go back, actually. How do I want to do this? Let's do this. So now I have 2 terminals. Let me open up the program again, and then let me compile and run it for you, okay? Or do I want to do that yet? Yeah, let me just show it to you very quickly. Do nothing. So here's me running the program that we just compiled. It outputs nothing at all, because it did nothing. Okay, that's the simplest possible program. And then I'll explain a lot more about what all these fancy symbols mean in just a second, okay? But that's the simplest program. We ran it, it did nothing. Now let me teach you the terminal, okay? And it looks like past me is reminding current me to do something special that you don't have to worry about. But this is more like what your terminal is going to look like. So let's make sure it looks like that. All right, so this is a terminal. You type little commands, and you hit enter, and it runs that command, okay? Especially, but you have to type the correct command, right? So this was not a real command name, but that's how it works. In the terminal, when you begin your life in the terminal, I'll open up a brand new one. You are plopped into, let me get there. When you log into the class server or you start a terminal on your own, you are plopped into what's called your home folder, which has a tilde as a shortcut for it, okay? That is your home folder, and it has to do with your user account. It's a special folder just for your user account, okay? If you want to see what's in there, you can type ls for list the contents of my current folder. Okay, there's always a concept of what is currently in your folder. Right now there's nothing, but in the folder where I'm writing your code from class, I just made a few files, right? I made this one, and this is something I saved from before that I'll show you later. I have 3 files when I type ls, okay? But right now, this home folder is empty, okay? So that's that. And ls shows you where you are in your what's called current working directory. There's always a concept of where you currently are inside of the terminal. What folder are you currently working inside of? By default, it's your home folder. If you want to see what really that folder's name is, you can say pwd for print working directory. That's what it stands for. pwd. So this is /home/lot. Okay, so that's usually what it looks like. It's /home/ your username. That's your home folder. Right here, it's actually in the terminal already, but this is where I'm saving your code from class right now. Home, lot, Windows Desktop, S22 code from class. These are all folders. Slashes separate them. CSCI40, Leco1. Okay, so this is my current working directory in this terminal. Okay, and so if I type ls, it's going to show me what's in that particular folder. Okay, if I'm in a different one, like my home folder, it's going to show me what's there. Right now there's nothing there, but there's stuff in the other one. Okay, so it's always depending on where you currently are. There's a concept of where you are. It's like the folder that you're in your file browser. If you want to go to a different folder, you can change directories with CD. That's what it stands for, change directory. Directory just means folder. So if you want to go to a different folder, you can say CD folder name, and that changes your directory to be inside of that folder. So let's say I go out to, don't worry about what I'm doing right now. Let's say I go out to my code from class folder, and I want to go back inside of my CSCI40 and this current lectures folder. So here are all my classes that I'm teaching. Here's a folder that I can go inside of and work inside of. Let me change my working directory using CD CSCI40. So now my current working directory is inside of it. So I used to be out here. Now I changed my directory to be inside of the CSCI40 folder. Does that make sense? Definitely yell at me. Come to office hours if you'd like a longer explanation of any of this. So now I'm in my CSCI40 directory, and I can see what's there with ls. I've only made one folder so far. That's the lec01 folder. Let's go back inside of that. lec01. And now I'm where I left off with all my .cpp files. .cpp is the standard extension of a C++ file. Okay? That's that. If I want to go out to where I came from, my parents' directory, the one above me, you can say cd ... That's a shorthand for my parent directory. So I'm in my lecture 1 folder. If I want to go back out to the CSCI40 folder that contains it, I can say cd ... And that brings me back out to the CSCI40 folder. Okay? And I can go back in with cd leco1. Yeah, ls to see what's there as usual. So that's the game you're going to be playing on the terminal all the time. Okay? That's the idea. Okay, let's just keep the rest displayed now. So yeah, to compile a program, we use a special command called G++. That stands for the GNU C++ compiler. It's just a brand of C++ compilers. It's the most common one, and that's what we're going to use. Okay, so we say G++ standard equals C++ 17, because that's like the latest and greatest version of the C++ language that we want it to compile with. And then you give the name of the file that you want to compile. So I already did it. Let me do it again. G++. Let me remove the old one. Remove do nothing. That was the compiled program. So here's just the CPP file. That is that program that I wrote before. Now let me compile it. G++ standard equals C++ 17 do nothing .cpp. If I hit enter, what it does is it just compiled it into ones and zeros for me. But if you don't tell it what file you want it to be called when it compiles, by default it becomes a file called a.out, which is silly. You can change that using a -o that I used before. But by default it's called a.out, and that's the program that you can run. Okay? If you want to run a program, you got to know its name, and then you put a dot and a slash before it. Okay? So that's the command to run a program. You just give a dot and a slash and then the name of that program. All right? It just says run the current thing, run this thing in the current directory, please. So I say ./a.out, hit enter. It did nothing at all because the program was supposed to do nothing. Okay? That's all. But it really ran. It really ran. So that is the terminal in a nutshell. You'll get more practice with that in the lab today, the lab time today. So that's that. Let's talk about editing code. I was writing a program inside of the terminal using what was called an editor, right? It's just like Notepad or something, but it's just on the terminal. So there's a ton of different kinds of editors. Those are just programs that you can edit files with. And they can either be terminal-based, like the one that I was using, or graphical-based, like a Notepad program or Visual Studio Code, if you've heard of that. They all exist. The easiest editor is called Nano. So let me show you that one, because that's the one that you should probably start with on the terminal. You say nano, and then a space, and then the name of the file that you want to edit, okay? And that either opens up an existing file or makes a new one for you. Okay, so let me edit a file on the terminal using the Nano program. So I say nano, then the name of the file that I want to edit. I'll just make a text file. Hit enter, it plops me into the file, and I can start typing things. This is a test file, blah, blah, space over, blah. And then when I'm done and I want to save it, I want to save my changes, I can say Control X. This caret down here is saying, that stands for the control key. So if I type Control X right now, it will try and exit and save any changes to. So it asks me, do I want to save? Y for yes. What file name do you want to save this as? The current one. So hit enter. It's already filled out for me. And now I just made a brand new file called file.txt. Yay. That was me editing it with a Nano editor. And I can rerun Nano on that file, and it will edit what was there. So here's me making some changes. I can use the arrows to scroll down. Here's a new line. Control X. Yes, I want to save. Same file. Enter. And then it's been changed. It's still there. All right. So that's Nano. You can use that to edit your files, but Nano only goes so far. It's a very simple editor. Very simple terminal-based editor. What I would like you to learn instead, when you have time, I'll give you time to do it today, is called Vim. That was the one I was working in. Okay, that's another terminal-based editor, but it's cooler. It's meant for programming. All right, the cool kids use it. It will give you a lot of street cred. So I can say instead, I don't know, Vim file.txt. It looks the same. Oh shoot, that was my fault. It'll look like this for you. Here is Vim. I was working in it in a different way. Let me do something just briefly. What do I want to do? That's what I should have done. So pretend nothing happened. There, that's the normal Vim that I like to use. So you just say Vim, name of the file, just like you would with Nano. And it plops you into Vim, and I can do cooler things here. Okay, I can select, copy, paste, things like that. So I encourage you to learn Vim eventually, and I'll give you some time for that today. So that's that. There's also graphical-based editors, one of which is called Visual Studio Code. I can help you install that and get a terminal on your own personal computer. And so you can use the graphical editor to edit the files, but you still need a terminal to like compile and run. I'd be happy to help you set that up. Okay? Let me know. Come to office hours. All right, so that's editing code in a nutshell. Hopefully that makes enough sense. Of course, I'll show you this a whole lot more in this class, so you'll get used to it. And yeah, let's keep going. So let me motivate like C++ for you a little bit, because you might be wondering, like, why did we pick this one to teach you? Why not some other language that you might have heard of? There are a few reasons. The first is it is on the low side of high-level languages, if that makes sense. There are a bunch of higher-level languages that do a lot of fancy things for you and make it so that you don't have to be as good of a programmer to get something done, okay? And so we like to make you think a little bit in this class so that you can go to an easier language later, all right? That's why we start you here. It's also very fast. It's probably one of the fastest languages out today, and you may have heard of like Python or something. Python, compared to C++, is so slow. Like, you can write the same exact program, and it will like take 10 times as long to run in Python. So it's also fast. And also, all the cool kids are doing it. Like, every Adobe program, written in C++. Every web browser, written in C++. Every game, for the most part, a lot of them, are written in C++ because they want the speed, right? All these guys want the speed. Your computer can only run things as fast as it can, and you don't want to slow it down with a slower language. All right, so that's why we're learning C++. And yeah, let's go into a bit more depth now on what compilation means, because I kind of glossed over that. It was very brief, what I said. So what in the world is a compiler? It translates a single program, right, your C++ program, to, let's call it machine code or object code. Those are the fancy words for ones and zeros, okay? So here is your C++ program. It was do nothing.cpp. And we sent that to a compiler, G++. And it spat out, for a split second, what was called object code. It made object code for just that one file. And the extension for object code, we'll see later in the class, is .o. But it really didn't make that file for us. It deleted it once it was done. So there's no .o file here. But it's secretly getting made, I promise. And then after it's done with that, after it compiled just that program, it translated it to machine code, then what's called a linker takes over. Okay? And it combines your program with other programs that are useful, that have been pre-made for you, so that they can share that functionality. So, for example, we're going to see later the IOStream library that lets you print to the terminal. Things like that. The cout, standard cout, which exists inside of IOStream. All this stuff that's useful, that's been pre-made for you, we want to use that in our programs, and so we'll import it. And so we want to, because we want to use it, we got to get that code from somewhere, and it's the job of the linker to bring our program with the pre-made programs together. All right? So it just so happens that the linker's name is also G++ for us, which makes it a bit confusing, but don't worry too much about it. So when I say compilation, at least at the start of this class, I mean the whole process, going from compilation for each individual program to linking to the final machine code program that can run on our computer, a.out. Okay, that's the idea. So after both of those are done, after compilation and linking, you have a program that you can run. It's in machine code. It's the ones and zeros that the CPU can understand. Okay, so that is the process. And now I want to show you real C++. All right, let me teach it to you, and we're going to have some programs that actually do things now. Okay, let me check our time. Yep, so this is all well and good. Yeah, let me make the simplest program that is useful. It's called the Hello World program. Okay, so it is it's custom. When you're learning a brand new language, it's customary, it's tradition to write a program that just prints Hello World and ends. Okay, so that's what I'm going to show you first to continue that tradition. Okay, so I'm going to make a new file called hello.cpp, and here is a C++ program that actually does something. It's going to print to the screen Hello World. All right. So here are a few things that I'm going to include. I'm going to explain them as I write them, and then I'll go into them in more depth. Okay. So I want to include the IOStream library so that I can get cout, and then I need a main function as usual. And at the very end, you always got to return 0. But before we get there, we want to actually print something. All right. So we're going to say standard : cout, and then I'm going to send the string hello, world, ! And then a new line to cout, and that will have it print. Okay. So this is the program. Don't worry. In a second, I'm going to explain it. But let me compile and run it. G++, standard = C++, 17, hello.cpp, hit enter. It overwrote the a.out file with the compiled form of hello.cpp. So if I run it, bam, did it print Hello World? Yay! It printed Hello World to the screen. Oh man, was that wonderful. All right, so yeah, we did it. Let's talk about what this program means. All right, so the first thing that I want to show you are comments in C++. Okay, so let me just start at the top. 2 slashes make a comment, make a single line comment in C++. This is just for the programmer. They don't get translated into machine code or anything. So you can write whatever you want after 2 slashes, and that's just a comment to you or to people who read your code. This is not getting translated or anything. You just write English, whatever you want to write. You can write there, okay? The first thing that's real that I do is I include the IOStream library, okay? This gives us access to, or I can actually put this on the same line, gives us access to standard : cout. That's where it lives, okay? And then a main function, this is called the main function. It's where the program begins. So all the code inside of these braces make up our program, that's getting run. Okay, so the first thing that I do is I give information to cout. Let me talk about the other kind of comment just quickly. You can have a multi-line comment, start it with a / and end it with a */. Okay, so this is a multi-line comment, because the 2 slashes just make a single line comment. This is, and it's my editor doing this right now, this is a multi-line comment. And then you end it with */. Okay? If you don't end it, it's going to think the whole program is a comment. Don't want that. All right, this is a multi-line comment. And now we can continue. All right, so yeah, IOStream gives us access to some really cool stuff. Standard cout, standard endo, which we'll get to. Really, really nice things, okay? You might be wondering, what in the world does standard : mean, right? When I say this, it's just getting something out of the standard library. Everything that exists inside the standard library in C++ is prefixed with standard : all right? It's just standard : blank uses blank from the library, all right? So it's cout that we're using, and what cout does, cout, standard : cout, is the terminal screen. If we send it information, we can print things. So here's me with some arrows sending information that way into cout. Does that make sense? And so I'm giving it some text to write to the terminal screen. Okay? I'm saying hello world, and then I'm giving something fancy. That's a \n. \n is a character, is a special character that means new line. Okay? It just presses enter on the terminal for us. That's what it means. So it's one big character together, but it starts with a \. So \n means new line. It'll press enter on the terminal for us. There's also \t, which types a tab for us. \r does a fancy thing called a carriage return. If you want to actually type a \, because it's overloaded like this, you have to type 2 to get 1. Okay? That's the idea. That's what's going on there. Yeah, that's what's happening. And so we're sending this thing in between quotes, which is called a string, okay? Like a string of characters, we say. Okay, so I'm sending the string hello world and then a new line to cout, and that is a full, complete sentence to C++, okay? Every sentence, every statement ends in a semicolon, you might have noticed. That's just how you complete your thought. It's like a period in programming land, okay? So everything, once you're done with a line, you end it with a semicolon a lot of the time, okay? And that's like, I'm done. Send cout just this, move on to the next line, okay? That's what's happening. All right, so let me show you what \n does. Let me get rid of it. Oops. Sorry, I'm doing weird things. Let me go back to the terminal. Let me recompile the program. Let me rerun it. Do you see the difference? This one is typing a new line so that the terminal starts over again on the next line. This one, when I ran it, oops, what happened? There it goes. Sorry, it deleted itself. When I run it, it's typing hello world, but it's not typing enter. And so it's just typing the terminal prompt on the same line once it's done. You see how the first one is much cleaner? So that's why we have the \n. Yeah. There we go. Yeah, so if I recompile, rerun, now it does it the right way again. All right, so that's that. Let's see what else. So yeah, \n is called an escape character. It's something that's getting replaced with something else. And that is what's going on there. All right, so we have access to standard cout. We used it. But soon enough, you're going to get tired of typing standard : everywhere, right? So wouldn't it be nice if we could just type cout and have it reference standard cout? There's a way to do that, okay? You can say using namespace standard up here. This lets us skip. Oops. The standard : bit. It's like, okay, just by default, use that everywhere. And so now I can say just cout. Yeah, now it's happy. Okay, that's something that I can do. And also there's a synonym for \n. It's called endl, or it's really standard endl. Yeah, but I just got rid of the standard everywhere. So that is that. And so this is another way of writing the exact same program. Recompile. I'm typing the up arrow to get out of my previous terminal commands. Rerun. It's the same thing. So using namespace standard makes it so that I can skip the standard : : So we also got endl now. So both of those live in IOStream. All right, so we're pulling them from there. This is our main function. It's where the program begins. We have 2 real lines. The first one is typing hello world to the terminal, and then also a new line. And then we are what's called returning 0. And that is just a customary thing to do. It's an integer. We have to give back an integer from main. This just says that it's called an exit code. We're giving it back to the terminal. And 0 just means success. Like the program ended successfully. If you return a different number, it means that an error happened usually. Okay, so that is the program in a nutshell. It's the simplest program that does something useful. All right, so yeah, this is pretty much the template that you'll use when you write code from now on. Okie dokie. So that's where I wanted to talk about there. Let me make a new program and show you some cooler things. Let's do just some simple math. Let's make a program that gets the area of a circle of radius 5 or something. All right. So let me make a new file, vim area.cpp, and include IOStream using namespace standard, int main, and it's always got to return 0 at the end. But before then, let's print out output area of circle of radius 5, let's say. Okay, so let's cout, oops. Let's cout 3.14, and then for multiplication it's a star, times, it's pi r squared, right? The radius is 5, so times 5 times 5 to make it squared. And then a new line. You can type as many things as you want when you separate them between these little arrows that send information to the left. All right, so let's compile now area.cpp /a.out because it's replacing that file always. And it looks like the area is 78.5. Okay, so it's doing math for us. That's nice. That's the next program. Yeah, one thing that I do want to say now is white space doesn't matter in C++. I could do this. C++ doesn't care. Like, I could say this, tab over, cout could be like that. From C++'s point of view, it does not care. This is the same program. It'll compile and it will run. Okay? But please be sensible. Try and write it the way I write it. It's much cleaner that way, right? So yeah, that's this slide. And pat yourself on the back if you understood any of that at all. We just made our own programs. We are awesome. Yeah? So just a few more things before we leave. But that's the bulk of the lecture for today. Let's talk about some types just quickly. Types of things. So the first thing that I want to talk about are variables. Every variable that you make in C++ has a certain type, all right, associated with it. So here is a line that makes a variable called x and holds 42. So like it makes a box in memory called x and it holds 42. Okay, that's what it's doing. And x is a special kind of variable. It only holds integers. Int stands for integers. So you have to say what type your variable is when you define it. And so here's what I want you to think about it as. Like, think of types as clouds, all right? So the int cloud, all the different kinds of things that can be an int are whole numbers, integers, 42, 6, 12, -88, 1, 0. Those are all integers, okay? That's the int cloud. There are other types of things. You can have doubles. A double is a number with decimal points, okay? Double. That can be your 3.14. So I was secretly using that already. 12.0, things like that. Those are doubles, numbers that can have decimals in them. You can have individual characters that you save. Those are called chars, short for character, of course. And characters in C++ are separated with single quotes, individual characters. Okay? You can have the space character as well, things like that. And then another useful type is strings. If you want strings, the type name is string. If you want to save it into a variable, blah, the, things like that. Those use two quotes. Okay, that's how you separate characters from strings of multiple characters. All right, so that's that. Let me show you those just quickly. What's going on with those? So I'll make a new file called vars.cpp. So let me quickly fill in my boilerplate of code, and let's do stuff. All right, so let's make int x equals 42. This makes a variable called x that holds 42. All right, so I can see out now, instead of saying 42, I can say x because it lives there. Okay, and so this will print 42. I can make a double, call it d, that's 3.14, and I can print d out. That works like that. I can make a single character called c, holds the, I don't know, let's have it hold the c character. I can output that on a line by itself, see out c, new line. I can make a string. If I want to use strings, though, I have to include the string library. Okay? I have to include the string library to use the string type. So every time you have a variable, you have to say what type it is. String s equals hello. All right? See out s, and a new line. Okay, so if I run this, vars.cpp. Yay, and so it prints all those things out on a line by themselves. So variables are useful because you can just have names for things that are much longer. Yeah. So that's that. I think the final thing that I want to show you is cin. You can get information from the user using not cout, but the opposite, cin. You can use that to get input from the user and to store it into a variable. Okay? That's what we want. So let's do that. Let me show it to you. So here is me using cin. I'll make a new file, cin.cpp. And so it still exists in IOStream. It's part of it. But yeah, let me show you all these things. Let's use cin to get stuff. Let's make a variable called x, but not give it a value yet. Okay? Let's ask the user for that value. So let's say cout enter an integer. I'll give a colon and a space. And then after this, on the same line, I'm going to ask the user to give us a value for x. Please type a number. So I can use cin for that. Okay? Cin, and it's the information from the, think of cin as the keyboard. We're sending that information into the variable, so the arrows go the other way. See that? So this gets input from the user and puts it into the x variable. Isn't that cute? And then you can use it later. Be like, you just typed the value of x, whatever it was. So this is different depending on the run of the program. So I'll recompile cin run a.out. So it says enter an int, and it's waiting for me to type because I typed a space, not a new line. And now I'm asking cin to take over. And so now it's waiting for me to type things. So I can type 42, hit enter, and it took that 42, put it into x, and now x's value was 42. If I rerun the program, 55, now it prints 55. Isn't that nice? And you can do the same thing for all these different variables. You can make like chars, doubles, strings, yeah. All of these things work just like that. So that is stuff that you can get from cin. So enter a, I don't know, enter a char. So read from the keyboard into C, read into D, read into S. And then we can print them all out. C, D, S. Here's the important parts of the program. Boop. Rerun. So 42, I don't know, C, 3.14, and hi. And it prints them all back out. It reads them from the user. Okay, so that's what cin is for. notice that the arrows go the other way because you're reading information from the keyboard and putting it into D. Whereas for cout, you're giving information to the screen. Okay, so that's cin, and yeah, now that is essentially all of the lecture that I want you to remember. I want you to practice a little bit now. So pause the video and think about, like, what does a compiler do? Which one of these? Okay, and we'll come back and we'll talk about it. So the answer, in fact, is C. A compiler, right? It translates high-level languages that look like English down into machine code that we can then go and run with our dot slashes. Yay. All right. If only it made us a PB&J sandwich. Isn't that nice? So what now? What's the last one that I want to ask you? What is the terminal command to compile a file? If the file you know, it's named x.cpp, how do you compile it? Right? And then what do you use to run it? Okay? So show me what you think. All right, so write that down, then I'll show you the answer. To compile a file named x.cpp, it's G++, right? G++ standard equals C++ 17, and then it's x.cpp. Yay. All right, and then to run it, it compiles it into a.out, right? So it's /a.out in the current directory. That's how you do it. All right? And so finally, the last thing that I want to show you today is not something that you have to memorize. It's just a fun little example that I like to give to show you the power of what you just learned. Okay? So here is Frozen's Let It Go. I'm going to play this. I can't let the sound come through to you because it will give like a copyright strike on my YouTube account. So sorry, you can't listen to it as I do it, but I encourage you to code this up yourself, or I'm going to give you the code, compile it yourself and run it and try it on your own where you can actually hear it. But I promise it works. And yeah, I've made a karaoke.cpp file. All right, so let me show this to you. This file is going to sing Let It Go to us, okay? So the stuff that we know about. Here are some new things. Don't worry, I had to look them up. Don't worry about this either. It's a function that pauses for a certain number of seconds, okay? So if I say pause 1, it stops the program for 1 second, and it makes it wait before it prints out the next line, okay? So we're just running a bunch of lines of code, and I made a special thing called pause that works for us, okay? So it's going to count down, it's going to print things, but really, this is everything you know. If I told you what pause is and just ask you to use it, you could write this program, right? You just got to get the numbers right. And so here it is, printing out using cout, and then just waiting a little bit, the lyrics of Let It Go, and it's going to be perfectly timed to the song, okay? It's going to print and wait, print and wait. That's all this program does, okay? And so let me try very hard to get everything situated in the same spot, but maybe I can make this a page just by itself so I can make it smaller. Yeah, I'll bring it up here, put it up here maybe, but let me compile this, G++, and karaoke.cpp, and there's a special thing you can do in C++. You can say -o, and then the name of the file you want it to compile into. Boop. If I say -o, it makes it so that I can save a file with a name as something other than a.out. Okay, so I can say I want you to call the file karaoke instead of a.out. So this is the full command to G++. Hit enter. It compiled, so it made karaoke. And now I can run it, and it's going to ask me to. It's going to count down, and then it's going to start running this program. Press play. So I'm going to try my hardest to time this correctly. So let me get ready with the play button. Let's make sure it's at the start. Boop. All right. 3, 2, 1, go. All right. So you can't hear it, but I can, and there should be lyrics on the video anyway. But notice what's happening. This is a program. It's right now waiting for 20.25 seconds, right, before it starts printing the lyrics of the song. And this is all stuff that you know how to do now. Just a bunch of lines. Print and pause. And oh man, is it working at the same time. So this is much cooler if you get to listen to it at the same time, I promise. But I think it's still cool right now, yeah. So definitely code this up, or copy this code, run it yourself, go to this link, listen to your computer sing, let it go to you, okay? And to stop a program before it's finished, because this is going to take a while, you can use Control-C. So that's what I'm going to do right now, okay? So yeah, definitely get to the chorus, have it be cool. But that is the last program that I wanted to show you today. So that is the first main part of the lecture. Now we're going to have lab time, because usually I either introduce a lab or have you do something in lab, have you just work on your current lab. There is no lab out yet. There's going to be a lab out after the next lecture. It'll all look like 1 week to you. It's not a big deal. But I want to teach you more about the terminal, and I'll just make a separate video for that and put it underneath this lecture. Okay? So, yeah. Take a 10-minute break like you would in class, and come back for lab time. I'll see you then.